Good. All right. So we good? Good morning, everyone. So this time we're going to deal with the learning objectives for inverse functions. So let's read first what are our 4 objectives for such. Once again, lesson 1.7. All right. Go ahead. Can you see it from there? Go ahead.
Verify inverse functions, determine the domain and range of an inverse function, and restrict the domain of a function to make it one-to-one. Find or evaluate the inverse of a function. Use the graph of a one-to-one function to graph its inverse function on the same axis.
Thank you. Right. So as we notice in here, there's always that term one-to-one function, right? And hopefully you can still recall from lesson 1.1 how do we determine what line test should we use to determine if a function is one-to-one. Horizontal line test. Very good. Okay, that's correct, right? So this time we're gonna use that one to deal with our function in here. We are given f of x is equal to what? Cube root of 3x plus 1. We have to find what? The f inverse of x, right? So again, for the definition, if you see that notation, f inverse of x can be read as that, as such, right? So when you see that one is not an exponent, right? It's not f to the negative 1 power. Rather, it's just basically saying it's f inverse of the given function, f of x. Are we good? All right. Let's read this one and see how our steps in here will tell us on how to determine the function or the inverse of a given function, right? Let's read step 0, right? Let's read step number 0 first. Good. Aspen, you see it from there? Make sure
that the given function is one-to-one horizontal line test. Typically, you can cut the function as its vertex to make it one-to-one.
Thank you, right? So again, let's see our given in here. So we have our given as such. What is that? In here, for number 20, for example, we are given what? Cube root of 3x plus 1. Alright? So basically, let's grab it our Desmos calculator and see how it looks like. Put it in here like such. Once again, you click in here, right? On the tools, click on what? Where's the cube root in here? Go to functions. Get it? Right? So follow along, guys. If you scroll down, you would be able to see under the number theory group, you would be able to use that. That's nth root. Alright? See that one? That's nth root. And just basically put in 3 as an index, right? That's the cube. Are we good? Right. Once again, go to tools, go to functions. Under functions, you scroll down and you would see the number theory group. You would be able to see that, right? Nth root. So that's cube root of what again in here? 3x plus 1, right? 3x plus 1. And verifying in here, click on home. Look at that one, right? Is it one-to-one or not one-to-one function? Using a horizontal line test, right? Is it one-to-one or not one-to-one?
It is.
It is one-to-one function, right? So since it is one-to-one function, then we can go to step number 1. Are we good? Right. Once again, how do you know it's one-to-one? Draw a horizontal line, right? If it will always hit it at one point, only one point of intersection, then yes, it's a one-to-one function. If not, then cut along the vertex, right? We good, right? Or where the inflection point is. Either you go to the right side or the left side only of the domain, then that will make it one-to-one. Right. Next, what's now our step number 1? Let's read it in here, okay? Okay, go ahead.
Switch the x and y variables.
Thank you, right? So for given this in here, then that means f of x is basically your y, right? And cube root of 3x plus 1, right? For step number 1, what do? We switch the x and the y instead, right? So with that, then this will now be what? See? This will now be our new x, okay? And now this one will now be our new y, okay? Right? And do the same, right? Cube root of 3y plus 1. Okay? So once again, our step number 1, whatever your x is, make it y. Whatever your y is, make it your new x value. Are we good? Questions, guys, with our inverse, right? That's basically always the first step for such, right? To switch the x and the y values, right? What's step number 2? Right? Let's read step number 2. Angelina, go ahead.
Usually we flip left and right sides.
Thank you, right? Why do we typically or usually flip the left and the right side? Simply because you want to solve for y. And when you say solve for y, then that means y should always be what? On the left side of the equation on its own. Are we good? So basically in here, what do we do? We flip the left and the right sides. Okay, so that basically will give us the following. This will be in here. Cube root of what? 3y plus 1 is equal to x. Get it? Okay, so again, we just flip the left and the right side. Why? Once again, because you want your y to always be on the left side of the equation on its own. Get it? Okay. Step number 3, right? Let's read our step number 3. Okay. Corey.
Solve for the new y.
Solve for the new y, right? So you see this new y in here? You want that on its own, on the left side of the equation. In short, get rid of this, this, and that. Okay? So what do we do first? What do we need to get rid of first? The plus 1, the times 3, or the cube root? The cube root. Very good, right? How do we get rid of the cube root? Cube. Both sides. Very good. That is correct. So that's what we're going to do first in here. We're going to cube both sides, left and right, right? Since these two are inverses, they're going to cancel out, right? Hence, we got what? 3y plus 1 is equal to x cubed. Get it? Okay, so we got rid of the cube root already, right? By cubing the left side and the right side of the equations, right? What's next? Niste. What do we need to get rid of first? Next, by the way. The minus 1 both sides. Very good, right? Get rid of plus 1 by minus 1 both sides. Very good, that's correct. Cancel this. We got following. 3y is equal to x cubed minus 1. Alright? Oh, what's the next step? Hampton. What's the next step? What do you think? We just want that y. How do you get rid of the 3? Divide, very good, right? So you divide both sides by 3. There we go. Right? So this will cancel out. Hence, we got the following now, right? Your y, again, this is your new y already, right? Is equal to what? X cubed minus 1 all over 3. Okay. Oh, what's next? What do we do next, right? Since we have solved for the new y already, your y is on the left on its own. Okay? What do we do then? Step number 4, okay? Yeah, go ahead. Step number 4.
Verify by, or wait, no, by 4.
Yeah. Just change the uy into what?
F and negative.
Yeah. What? How do you read this one once again?
Inverse of F and
Very
X.
good. Right. So whatever your new y is, you just change this one to the notation f inverse of x, right? So whatever this is basically your what? Your f inverse of x. Okay. Are we good? Right. One last step is what? Step number 5, and let me read it for you guys, right? So sorry, this will be just not a space in here. Verify by graph. And how do we verify by graphing? It says in here that the given function f of x and your derived inverse function, so this and that, those two, must be what? Reflections along y equals x line, right? So what do we mean by that? Let's see in here, right? So you see this one is our given function, right? Cube root of 3x plus 1. Are we good? Okay. Now where is the inverse function? So our inverse function once again is what? It says in there x cubed minus 1. So let's put it in here like such. X, okay, cube. Here we go. Minus 1. Get it, right? And then I divide it by what? The entire thing, the entire expression, I divide it by what? 3, right? So. See the purple and the black, right? Are they reflections of each other? And where are they reflections of each other at? I'm going to put in here y is equal to x line, right? Now you see what's happening here, guys? See that one, right? This is the y equals x line, the one in red. You good? Right? The given function in purple is the cube root of 3x plus 1, right? And the inverse function in black is the, what's this? X cubed minus 1 all over 3, right? What do you notice? That if you fold, right? Supposing this is a paper, if you fold this paper along that red line, then that means the black and the purple would what? They would trace each other out. Are we good? Get it? Right? So again, that's how we can verify if they're actually correct. Get it, guys? Okay. Any questions? Are we good?